sphere?
I can. No, I can't about
This picture just like motivates me.
maybe it's like, maybe it's
What is it?
diameter times area.
Could be diameter.
Times diameter.
There is a characteristic or a measurement of circles that applies to everything you're figuring out with circles.
Pi.
Base times height.
You gotta have pi in there, and what's the other thing? The radius. Both of those things are in play here. You need a pi, and we need a radius. It's just what we do with them. If it's pi radius squared, that's area. If it's 2 times pi times radius, that's circumference. So what's volume? What do you think we're probably going to do for volume?
Multiply the
Area.
base times height
She's hinting at what you need to do. She said multiply 3 things. Base times height times something, right? But this doesn't necessarily have a base.
Oh, surface area?
Surface area is different. Like this is surface area here. So when we come out to the next dimension, that gives us volume. But what do you think we're going to do with the what do you do with the radius when you're finding the area?
Square.
You're squaring it. What are the units anytime you're talking about volume? You're talking about cubes. So for your volume of a sphere, you need to cube your radius.
Oh, wait, that makes sense because you have to bring it out.
Yeah, because the radius is this way and that way.
Yeah.
There's a coefficient though. Michelle, did you find what the coefficient is?
Yeah, it's 4/3.
It's 4/3.
Aw, right.
Just so you have it for your reference, and you'll see a really cool relationship between these two things next year in calculus. Your surface area equation is that, 4 pi radius squared. But this is what we need. We need the volume of the sphere. And what else are we going to need? We need the volume of this thing and
Of the room.
the volume of the room. So how am I going to find the volume of the room?
Base times
That's not so bad, right?
Times width.
Those are right.
Well, we have to split it. We have to split it.
Or
Wait.
the office.
Is it
Let's
gonna,
just go the whole thing. We'll go right to the office. And it'd be easier to fill up the office, but
You're like the
I
photographer
did.
in here.
It's the remote. We need the volume of the room,
like
which,
everything? Base times like the office too?
yes. All right, so how am I going to get my radius here?
Oh, you're
Now
not gonna
copy
go
it.
through it.
Hold it.
Because I hate balloon
No,
spot.
like here. Measure from this to this section.
Yeah.
I can see it.
Draw a radius for me.
Oh, God. Are we not counting this bottom part?
Yeah. I'm not counting. I was thinking sphere. Hey, what is that one thing? Never mind. You keep going. While she's figuring out the radius, I need to figure out what in the room.
The base.
Volume.
Alright, so I need the height.
Maybe do it the other way.
What's your guess? How tall is this room?
How tall is it right now?
How tall are you?
9.
10 feet?
No,
How tall are you? How tall are you?
How tall are you?
Good.
I'm a little under 6 feet.
Actually,
I think it's a good 11.
it's under 10.
9. So it's about 9.5.
Is that tall as your finger?
Yeah, let's say 9.5.
It's as tall as Mr. Panko.
Your height's 9.5. You write it down, Drew? Oh, yeah. Your height's 9.5. I need the length and the width. All right. Now, yeah, we got some things jotting out here, but. And if you ever get into carpeting or flooring of any kind, and you need to do an estimate for surface area,
You're gonna hit your hand.
yeah, but it's not going to do anything.
Like my dad always yells at me for doing it. He's like, "You chop off your finger."
So that was 25, and now we're at 6.5. So, want to call it 31? Just so we don't know, or 31 and a
Well,
half.
32. We gotta get overestimate
All right, so let's
money
go 32.
For a balloon.
for a balloon.
Is that the width of the length?
Like.
Length? I will call it the length. I gotta go this way. What was it? 30, 32? 30, what would we say? 32, yeah? Alright, so this is only taking me to the wall.
The window. The wall.
No, don't see the rest.
And we have 23 and a half, we'll call it 24. Plus, you almost have that radius?
Wait, what was the what?
Yes, Drew. So far we're at 20. Now if I held it out straight, and I went from here to the end, you see what happens here? Bend across, and now it looks like it's 6 inches. Well, if we actually kind of eye it up from the center, how many inches does it look like? Like 4? Yeah, I can see 4 right here. Am I still at the center? Still at the center, basically 4 inches. So which is our actual radius? 6 or 4?
Oh, it's 4 because that's even straight.
Yeah, because if you like kind of cut it in half, like
I would not.
if you cut it into like half a sphere and you did it, if you did the radius from there, it would have to be straight.
So if I was able to cut this balloon,
Yeah.
what would my cross section be? What would it look like if I sliced this thing? It would be
It would be
A
Half a
semi-sphere.
dome.
a semi-sphere, okay. Or what basic figure? If I just cut one little slice right out of this thing.
Oh, it's
Pie. Slice.
Okay, like a pie slice. If you cut it,
Oh wait, you're talking
Laterally,
about half.
right?
Okay.
it would just be a circle. If we slice a sphere, I'll have to find a picture of what that looks like when we slice a sphere. But you're just getting these vertical sections. You're just getting these big circles that are going to stack on top of each other. And unfortunately, if I had kept those little models that I just gave to Miss Merkel, I could have showed you that.
I'll go pick it up.
That's all right. She needs them, and I've kept them for too long. So it would just be a circle. And it's a circle. What's the greatest circle?
in the center.
It would be from the center, right? It would be the one that kind of hits the peak of this balloon here. So it looks like we'll call it 4 inches, because I see 4 here, and we have balloons of different sizes. We'll call it a 4-inch radius. Do we need anything else? We got the radius of the balloon now. We have the dimensions of the room. Do we have enough information to figure out our volumes? Yes. All right. Oh, that's the other thing. And I might as well mention that because I don't know how much we'll get to talk to it. On a sphere, if you measure this way, if you go around the circumference of the sphere, that's called a great circle. Just a nice little. Oh.
Fun fact of the day.
All right, sphere. What do we got? We have 4/3 pi. What's our radius?
4.
4. Let's make sure we keep our units in check here because we're going to have some different things. So we get, what's 4 cubed? 4 times 4 is 16 times 4 is 64. So we get 64 times 4 is 216? 256. Thank you. So this is 256 thirds pi inches cubed. Exactly. Let's get an approximation on that because I can see us cringing at the fraction and an irrational number next to each other. Yeah.
85 and 1/3.
How much?
85 and 1/3.
85 and a third?
Yeah.
Double check her. It's true?
Yeah.
So that's what that balloon is, 85 and a third cubic inches.
So multiply by pi.
They didn't multiply by pi?
That's just the
No, it's 268.
Yeah.
I could simplify to 250 something. I thought we finished.
Yeah, it's 268.08.
268?
0.08.
0.08?
It's ugly. If it reached me, it would have been better.
All right, what about the room?
It wasn't.
Drew, what are our measurements again?
9.5.
9.5 what? Okay.
32 feet
And
and
there's basically 82
and then 36.
by 36. I really hope you guys are online about it.
I put it away, I swear.
Yeah. What's our volume?
So what you said?
I'm pretty sure they were on Monument Valley when Mr.
Yeah.
Pace came in.
I was talking about
I
the
got
balloon.
340.
How much are you getting?
340.
340?
Oh, never mind.
I got it's 10,940.
79.
Oh wait, then don't you have to like?
So we got to get from cubic feet to cubic inches. Or from cubic inches to cubic feet.
Okay, 131.
You'd rather go feet to inches.
131,300.
Oh, so then you have to.
Inches.
How much?
131,000.
131,300.
20.
How'd you get that?
And multiply it.
Wait, but can't you not do that?
You cannot do that.
Don't you have to multiply it by like 1,728?
What's 1,728?
12 cubed.
12 cubed. Nice little thing to remember when you're converting. So if you have a cube here, I never get my dotted lines right. I never put them on the right spot. So you have a cube, and we need to go from cubic feet to cubic inches, or from cubic inches to cubic feet. So draw yourself a little picture. The same thing's going to happen with squares. We forget the conversion a lot. So pretend you have a cube here that's 1 foot by 1 foot by 1 foot. That's the same as 12 inches by 12 inches by 12 inches. And if you wanted the volume, here we have 1 cubic foot. How would you get this in terms of inches? What would you do? 12 by 12 by 12, which would be 12 cubed, or what was it? 1,728 inches cubed. So a cubic foot is that many cubic inches. So now we have 10,944 cubic feet. What's going to happen when I go to inches? Is that number going to get bigger or smaller?
Bigger.
It's going to get bigger because it takes me more cubic inches to get a cubic foot. So I'm going to take this room here and multiply by 1,728 cubic inches to get
Oh, that is so
18,911,232.
big.
18 million?
Yeah, 911,232.
Just out of curiosity, if you were at 268.8 cubic inches and you wanted to go down to feet, what would you do? You would divide it by 1,728.
No.
Well, I mean, you would get that.
So let's make a little proportion for ourselves. We have 268.08 cubic inches, and we want to know how many cubic feet that is. What relationship do we know in terms of cubic inches to cubic feet? Yeah, the 12 cubed one, so the 728 cubic inches is the same as 1 cubic foot.
Oh, yes.
So what are we going to end up doing mathematically here?
Dividing 268.08.
So that means that balloon here, again, it's got the little end part, but this balloon is not even 2/10 of a cubic foot, which doesn't seem right, but where's my balloons here? Give me 2 more balloons. You said this was like 4 inches, right?
There's one right there.
So I would need how many to make up a full cubic foot? A lot of them? Well, this is 4. About, if I need to make up a cubic foot, how many balloons wide do I need to go?
You want more?
7.
Just go width. If this is 4 inches,
3.
So this should be about 4, and this is about 4.
Yeah.
So lengthwise here, or side to side, we're about 12 inches here, and it looks like it's a little bigger, but you know, balloons are big. Oh, wait a sec. This is a radius of 4.
Yeah, the diameter.
So the diameter is 8.
Oh, you're right.
8, 6.
Well, that makes it harder. You need to cut one of these balloons in half.
No, you don't.
Very good.
No, you don't.
All
Well,
right.
this one's tiny. No.
Yeah.
I'm sorry.
Well, we get the point, right? This is going to be at least 2 here, and we got 2 stacked on top, and then we're going to have 2 more back here, and 2 stacked on top of that. So that's at least 8 balloons.
Yes.
Would 8 balloons make up the cubic foot? What's 0.15 times 8? Yeah, 0.15 times 8. 1.2?
Yeah.
1.2, so it's a little bigger. But that's the gist of it, right? You got 2 by 2 by 2 by 2. All right, so that's what's going to happen inside the room here. Now what's easier to work with? Let's stick with the inches over there. We got 18 million inches, and there are 268 for each one of those balloons. So what are we going to do with those 2?
Oh, sure, yeah, you're not right. Yeah, I'm at the end of season 3.
There's a little tiny
wow.
balloon
Okay.
right there.
The last
What do you get?
Much less than
I have 70,543.
70,543.
About. You said 7,000.
I said
said
700,000.
Oh, you did?
Yeah. Can we test this?
What's that?
Let's test
How many balloons would each of you need to blow up if we need 70,000?
How many for
15.
4,702.
Oh,
We can
How
do
much?
that.
4,000?
4,702. These all pass out.
You're gonna take like
This is like 2 years to build this classroom.
How long does it take you to blow up a balloon?
about like 30 seconds.
Yeah, it
How
depends,
long
on,
did it take you guys to blow up these?
it depends how big you want.
30 seconds?
Yeah. But then to tie
Well, it
it
depends on each person's balloon.
All right, so let's say
They're tying.
Want to take an air call?
blow and tie a balloon. Blow up and tie a balloon.
45.
Yeah, 40.
45 seconds?
No, maybe. No, I think 2 minutes.
How about we test it out?
Who's got a stopwatch?
I have a stopwatch.
Deja's got it.
I don't know if I have one.
I need a balloon.
Time, time.
You don't have any more balloons?
No, I have time. We're gonna tie.
No. Balloons they're going to take it's a good 5 minutes to untie.
Okay, and we'll make up those 5 minutes if you're blowing them up.
No.
How about you continue?
Well, if it was a minute, it would take you guys about 4,700 minutes to blow up.
How much cost do you have?
How many minutes is 5? You have to tie it too. Come on, Drew, 45 seconds.
That's not 4 inches. You got to get more
Oh
than
my
that.
god. Can you get a redo?
Yeah, that's
please?
good. That's good. He does not know.
So
Time
I'm
fast?
terrible at time.
Oh, you should have told us that.
There, done.
He's done.
27,
What if some?
52 classes?
About a month and a half.
So that would take us into the second semester.
That's fine. You know, pre-calc will.
But then we get more students in
We get
pre-calc.
more
Yeah, we'll
students,
have
so
some
we'll
more
get
help.
it quicker.
Are you seriously serious?
What's that?
And it might take a
No.
little longer because we have to give you a little time.
Biggest angle? Smallest angle is across from?
Smallest side.
Smallest side?
Usually smallest angle.
Yep. What requirements must be satisfied if you're constructing a triangle?
The 2 smaller sides have to be.
Greater
Greater than
than
Don't you have to do it for all 3 sides though?
I did it for one.
Yeah, I was a little confused because.
That's the direction.
Yeah,
The direction did say that, right?
I
It
did
said-
like ranges.
So you had,
Because some of them, like,
do it like 3 times.
yeah. But you end up getting overlap, right?
I want to pop
Wait,
this.
3 times what?
In your inequality, you end up getting
Yeah.
getting overlap.
We do it 3 times, you have a negative, and you have a positive, or depends on-
Yeah. So, do you have to do it all 3 times?
I didn't do that.
Technically, no.
Because
Well, realistically, no. Technically, yes. The theorem is any 2 sides must have a sum greater than the third side. So you test any 2 sides. But you guys are looking at it and saying, well, I'm not going to add up 15 and 20 to see if it's bigger than 7. I know 15 plus 20 is bigger than 7. So you're going to test the 2 smaller ones and see if it's bigger than the third. And I'm fine with that. Here we go. 348. 8 to 18. Measures greater than angle 2. Angle 4. Measures less than angle 4 are 1 and 2. Number 10 measures less than angle 5 are 7 and 8. Number 11 measures less than angle 9 are 1, 3, 6, and 7. Measures greater than angle 8 are 2 and 5. And measures greater than angle 7 are 5 and 9.
Yeah.
Oh my God, Jordan, I got so confused.
So you have it numbered. What problems you did?
8, 10, 12.
Okay, so then you just listen to the even ones.
I thought that was part of
Number
it.
8
though.
was angle 4. Number 10 was 7 and 8. Number 12 was 2 and 5.
Oh, I did all of them.
yeah, now we'll.
Yeah, me too. But hold on, I think it makes sense.
Also have
Oh, I did not see
some
even.
kind of, like,
So if it's greater than... Oh, that makes so much sense.
What about 9?
Because angle 4 is the only exterior angle.
What about 9 through 12?
Yeah, the number.
So it's only one angle.
Yeah, like less than angle 5 has.
Alright, so in number 12, you're looking at an angle 8, which clearly looks like what kind of angle?
Oh, cute.
It looks like an acute angle. Do you know it's an acute angle? You know nothing about its measure. You just know that it's on the inside of a triangle. So technically it could be acute and it could be obtuse. So according, as they say, to the exterior angle inequality theorem, you can only make comparisons with those exterior angles. So sure, it looks like 8 smaller than 9, but
You're not sure.
you're really not sure. Anything else in 8 to 10 you want to go over? Again, you're only comparing the exterior angles to its 2 remote interior angles. What was 10? 7 and 8.
What was 12 again?
12 was 2 and 5. $14. Bless you. Bless you. Angles, smallest to largest, WYZ. Sides, YZ, WZ, WY. 16. Angles, HJK. Sides, JK, HK, HJ. 18. Angles, STR. Sides, RT, RS, ST.
Wait, no, you said.
You said 16 first. Then.
Yeah,
Yeah.
16. Angles, HJK. Sides, JK, HK, HJ. 18. Angles, STR. Sides, RT, RS, ST.
Wait, no, you said.
You said 16 first. Then.
Yeah.
18.
Oh, what is? Oh, that's not for number 18 then. Okay, I'm sorry. 18 is ABC, BC, AC, AB.
Yeah.
Okay, that makes more sense. Because ST and R don't exist on triangle.
In England? Huh?
In England, no, they don't use those letters.
I heard England.
In number 22, XYZ are the angles in order from smallest to largest. YZ, XZ, XY were your sides, smallest to largest. 24. The angle with the greatest measure is angle 1. 26, angle with the greatest, nope, you had to do 25. Angle with the greatest measure is angle 2.
No, we didn't.
No, it was 26.
We're going
It was
to
22.
I'm looking at the second set of problems.
22.
Good. There you go, Tufts. Angle 1 is 24, angle 7 is for 26, and angle 3 is for 28. Good.
7.
Yep. In 30, ABD is greater than BDA.
Yeah.
In 32, BFD is less than BDF.
Yes.
In 34, SM is less than MR. And in 36, RQ is less than PQ. Any ones you'd like to discuss?
I did like how like the overall time like both triangles like the smallest and greatest, or like they were both angles are greater than the third side, and both sides are greater than the third. Compared to some both sides or not.
For number 30 and 32?
No, for 30, yeah, like all those.
Oh, so you have the, or you just have an extra angle or an extra side listed.
Yeah, it's not like that. But then something.
That's all right. It really just one of those two angles, but you just have a little extra work. Okay, to move on? What'd you do? What'd you take? Sinister. 367, 6. You cannot make a triangle out of 4, 9, and 15. I know. Number 8, you can also not make a triangle. You cannot make a triangle in number 10 either.
Why not number 8?
Yeah, I did it in order. I mean, I know why you can't. Since, like, I didn't know what they were asking.
It's because you needed to put it in order of
Because
numbers.
It says, Jordan said, you need to test all 3, or you need to make sure that your 2 smallest are greater than your third. And in number 8, your 2 smallest sides are 1.1 and 8.2.
Look who's here.
You lied, it took her 40 minutes.
Yeah. 30.
You missed the
No, they're still here.
Huh?
In number 12, your possible side measure is between 4 and 12. In 14, your side measure is between 1.5 and 6.9 centimeters. And in number 16, your third side is between 2 3/4 kilometers and 3 3/4 kilometers.
I'm not talking about the first one, right? It's gonna be greater than 0 and less than standard. I hope that's
Between 4 and 12. So 12, 14, and 16, again, what Jordan mentioned, what were the side measures? 4 and 8. Give your third side measure some dummy variable.
What is in it? I want to see what was in it. Ew.
There's sand in it.
Yeah.
Yeah, that was the one that had some particles in it. But Drew's gonna blow it up. I'll do it.
Here, I'll tell you.
He's a hockey
I
player.
did that the
so
first time
anyway.
anyway.
After we're done with this, you're gonna do that.
You're asking a casted,
Guys.
not lucky to throw.
This is the simple stuff. And again, this was examples in your text. You need to check 4 plus 8 needs to be greater than S. 4 plus S needs to be greater than 8. 8 plus S needs to be greater than 4. And now see what your inequalities present to you. We have S is less than 12. We have S is greater than 4. And we have S is greater than negative 4. So where does our S value actually live? Can't be, well, yeah, it's definitely going to be greater than negative 4. It's not going to be any of the negatives. And it also can't be 0, because you can't have a side measure of 0. But even if you go down to 1, you would have a 1, a 4, and an 8. So that would be 5 is greater than 8, which doesn't make sense. So once you figure out that extraneous inequality, that one that doesn't make any sense to this solution, you got to go to the next lowest inequality, and it's right here. S value is greater than 4. So your S values are going to range from 4 to 12. $20 was next. 22. Let's see. Which route did you say was the shortest, Kenna?
I said Highway 4 and then Route 6.
4 to 6?
What?
Oh, hold on.
What?
Okay, I did it wrong.
He's going from his house to the sports complex, right?
Yeah.
So how many total miles would you go on Highway 4 and Route 6? 47 miles? And how many miles would you travel on County Line?
30.
Do you know what you did?
Must be County Line Road.
So it is County Line Road. Now part B is the real interesting part. The speed limit's going to determine which one is actually the faster route. The speed limit on County Line is 30 miles an hour, and on Route 4 and 6 it's 55 miles an hour. So which one ended up being faster?
Highway 4.
4 and 6?
Okay.
Yeah,
65 miles per hour. Stop.
So you're going 47 miles, and you're going 55 miles per hour.
47. 30.
What? You're going 47 miles, and you're driving those 47 miles 55 miles per hour. So you're going faster than a mile per minute. And on County Line Road, it's 30 miles per hour, and you're going 30 miles, so you're going exactly a mile a minute. Next is 24.
Yeah.
Your range is between 20 and 200 in number 24. In 25, your range is between 2 and 10. 26, it's between 4 and 20. In 27, it's between 1 and 11. And in 28, it's between 4 and 24. 24 is between 20 and 200. You okay with that?
Can you go for 26?
26, so you can check. Now, here's where you need to check all three, because you really don't know what the value of x is. It could be in between the two values. It could be the greatest, and it could be the smallest. So you have 8x and 12, so you're going to see 8 plus x needs to be greater than 12. X plus 12 needs to be greater than 8. And 8 plus 12 needs to be greater than 8x. Those are the three inequalities you're going to check, and then you're going to piece the three together to find a nice range. So what do we get? An x value greater than 4. We get an x value greater than negative 4. And we get an x value less than 20. So this guy's out. These are the same numbers we had in the previous one? 420. So it was definitely 4 and negative 4. So we have to be bigger than 4, less than 20. And that was it for that section, right?
Yep.
And your last section, applications of Pythagoras. Good? Yeah. 21 on 553. There you are. This is an obtuse triangle. Because your squares, the sum of your two smaller squares are less than your C square or the greatest square. In 22, you cannot make a triangle, so we don't care if it's acute, obtuse, or right. In 23, you make a right triangle. In 24, you cannot make a triangle. In 25, you can make an acute triangle. The sum of your squares is greater than your largest square. In 26, you can make an obtuse triangle. Your sum is less than your third side. 27, your x value is 15. 28, your x value was 17. And 29, your x value was about 9.8, or exactly 4 radical 6.
Wait, why can't you make a triangle for 22? Oh, it's not.
Anything else on those? No? Okay. 38. Your perimeter in 38 was 48 units, and your area was 96 square units. 39, your perimeter was 36 units, and your area was 60 square units. You didn't have to do 39, you had to do 40 though, and that perimeter was 32 units with an area of 56 square units. 38 or 40.
How's it going?
40, sure. What kind of figure is that?
A quadrilateral.
It is a quadrilateral. Can you be more specific than that? Trapezoid? 10? 8? Is that right? Okay. It is a trapezoid. You have two parallel bases and two non-parallel bases. You had to figure out the perimeter, so you need to know what that side measure is over there. So if you draw yourself, what kind of line is this called? Actually, I'll actually draw it instead of dotting it. What is it?
Is that right?
Yeah, it's an auxiliary line. It's an extra line you're adding in there.
Oh, I get it.
So if you do that, what's this measure right here? That's 4, and this is 6. And what's the measure of your auxiliary line? 8. So now you have a right triangle in here, and you should think about the Pythagorean triples. If you don't know your triples, I'm sure you guys aren't memorizing them. There is a nice little chart in the book that tells you what some of the triples are. This is a common one. It is a 6, 8, 10. 6, 8, 10 triangle. 6, 8, 10 comes from the 3, 4, 5 triple. 3, 4, 5? The other common one SAT likes a lot is 5, 12, 13. They used it 8, 15, 17. Oh, that was from number 28. Number 28 uses the 8, 15, 17. So here now you have a 10. So you have 10. 10 is 20, and 8 is 28, and 4 is 32 as your perimeter. And now you just need the area. So if you broke it up, if you drew it like this, now you can figure out your rectangle and your triangle. Or your area formula for your trapezoid. It's kind of base and height, base times height, but because you have two different bases, you need to take the average of your bases. Or base 1 plus base 2 divided by 2, and then times your height. So your area is going to be 1/2 base of 10 plus 4 times a height of 8. And 10 plus 4 is 14, times a half is 7, times 8 is 56. Anything else? What am I missing? 42. Your x values are between 6 and 2 radical 13. 45. Your x value is 10. 46, your x value is 15.
Wait, what was 42? I didn't hear.
Between 6 and 2 radical 13.
Okay.
Any of those last ones you'd like to discuss? All right, then I'm going to